Okay, and welcome back. We're continuing with the last two slides on this presentation, but nonetheless, probably very important slides. So, where do we get exposed? Let's go over this again. The first thing that we need to consider is that the Earth emits radiation. So there's always some amount of background radiation that we are constantly exposed to. It generally should not cause any issues, but nonetheless, background radiation always exists. Um, Second type would be air travel, space flight, and additionally to that, we could add living high above sea level. Very simple. So again, going back to the notion of distance. So the higher we are, the closer we are to the sun, the less atmosphere is there above us to protect us from the harmful effects of radiation emitted by the sun. So normally we expect attenuation of the radiation from the sun, with the most harmful rays being, of course, attenuated by the atmosphere, particularly by the ozone layer. The higher up we are, the less atmosphere is there above us, so the more exposed we get. So obviously, space flight being the worst, there's no atmosphere. I guess not too many people are usually going to space, but hey, maybe it will change. Air travel, on the other hand, is very common. We all do take airplanes, and so generally speaking, an hour and a half on an airplane is equivalent to having a chest X-ray, which in terms of risk can be an equivalent of smoking 2 cigarettes. So that's something to consider. An hour and a half is not too long of a flight. So when we're talking about a transatlantic flight and we're up in the air at very high altitudes on top of that, that's another thing we need to consider is usually when you fly across Atlantic, they fly very high because when you're up high in the air, you get very little air resistance. And so you're able to fly quicker and consume less fuel. So that's, of course, in turn, then warrants higher irradiation. Medical radiation, that's a fair bit. So we've got quite a few things. We've got CT, we've got X-ray, we've got nuclear medicine. So different types of radiation. We'll talk more about this in the next slide. But yes, very much so it exists. Radon gas. Now, radon gas is an important point to make. I don't think too many people are aware of this. Radon gas is gas that's emitted from the Earth. In certain parts of it, certain parts of the Earth, there's more of it, just by means of chemical composition. This gas is radioactive. Um, it presents most danger when in climates that are cold. So basically, what happens is you breathe it in, it's radioactive, causes damage, end up with all sorts of problems. What happens is that in cold climates, it tends to collect in basements, and it has no odor. It is impossible to detect unless you have a radon meter, um, which over time can very much cause various health issues such as malignancies. So what happens is that in the winter we tend to keep our windows closed uh, in efforts to maintain heat level at sort of reasonable level. Anyways, so it's recommended for certain cold parts of the planet to have radon meters installed. That's one of the things that if you do have radon, you may need to have additional ventilation just to have that gas diverted instead of collecting in the basements. So radon gas. Nuclear fallout. So a nuclear fallout is, of course, uh, comes from both various explosions of atomic bombs for testing and for actual killing purposes, as well as various nuclear accidents. Of course, the largest one being Chernobyl. And as a matter of fact, most of the information of the um, various effects of radiation, most data, despite the fact that we've collected quite a lot from the explosions in Hiroshima and Nagasaki. Of course, most of it, certainly stems from Chernobyl accident. But this is not the only accident. We appreciate that there's been other ones, but the magnitude of Chernobyl far supersedes any other ones in the any predecessors. Even the recent ones in the Fukushima nuclear plant has had some impact, and certainly we've seen water contamination, but still, there's no comparison to the magnitude of damage that was done at Chernobyl. Radiation from the sun. So we need to appreciate the fact that, especially in light of all the ozone holes that are in existence, we all know that they exist, you need to be careful with exposure to the sun. There's higher possibility of potentially developing skin malignancy, so do use sunscreen, basically, long story short. Medical radiation, and that's our last slide, but that's something that we need to that's something that we need to be very considerate of, something that we need to have appreciation of. So various modalities will cause irradiation of human beings for diagnostic purposes, those being X-ray, computed tomography, angiography, whether interventional or diagnostic, nuclear medicine, which we now call molecular imaging. Everything except for NucMed uses X radiation. MI, of course, or NucMed uses radioisotopes. So different types of radiation, but the end result is the same. 50% of all of that comes from CT. So that's something we need to consider. CT is very widely used and very high dose modality, very necessary, but very necessary. So what can we do in order to decrease the unnecessary irradiation of humans? So the most important thing that we can do is we need to decrease the number of unnecessary tests. And that is, they're done for various reasons. They're done for the reasons that we suspect something, but in reality, it turns out to be something else. That's probably the best case scenario. Then there's worse parts. There's parts when, say, a doctor may not know what's the best test to rule out one or another pathology. Fortunately, here in North America, tests such as CT or MR are protocoled by a radiologist, by a doctor that will take into consideration the clinical information, the pathology that we're trying to demonstrate, and then not only they call it suggest, but they protocol. So they will in turn turn around and either agree or disagree with whatever test was ordered, and their word will be the final one. So if they say that you don't need a CT, you need an MRI, that means you don't get a CT. So we want to do the right test to answer the right question, sort of, not just do them to satisfy some kind of idiotic behaviors, worse than them being Googling things and then reading up something on the internet and then demanding from your doctor that one or another test gets done. That's the worst thing that one can do for themselves. But of course, educating physicians as well as things change. And that's a prominent problem in the rest of the world where, they don't have that kind of protocoling system in place where anyone can just go and get a test done, no problem, as long as you're paying for it. So that's one of the things to consider. We need to educate surgeons and non-X-ray staff on radiation protection, and they do get a certain amount of education. But again, is it enough? Is it not enough? It depends. It varies from person to person. But yes, we need to certainly tell them that the pedal that you're pressing is not just a pedal that makes sound and gives you a pretty picture, but there is serious potential of damage. They usually are very appreciative of that, but that's part of the scope of work of an X-ray technologist. So we're supposed to educate. And the final point is raise public awareness of true, and emphasis of the word true, radiation dangers. The public tends to have very skewed sort of understanding of what the real dangers are. People are afraid of things that don't even exist, but then real dangers get omitted. Long story short, radiation is dangerous, but pathologies are much more dangerous. And if your doctor has ordered a test, it's in your best interest not to argue with them and do what they say. They are professionals. They know the potential damage that radiation can do. They were supposed to have considered it and figured that the risks of not doing this test usually far outweigh the risks of radiation exposure. So that in turn concludes our little talk about radiation protection. I hope this was useful. Some of you find that we're missing something. It's because we're missing a lot. There's a whole world that we haven't talked about. So there's a lot of things that really need to be considered as far as radiation exposure, as far as interaction of radiation with living tissues, as far as what kind of division is employed by a cell. So it's a whole science that we've touched very superficial, very perhaps key points, but nonetheless very few of them. Nonetheless, I'm hoping that this has been a useful presentation, and if one's interested in knowing more, lots of resources on the internet. Of course, just like with anything on the internet, you need to be careful of making sure it's correct and valid. Thank you for